This video is about gold prospecting in southeast Denver. The vast majority of precious metals produced in Colorado came from the mountains, but it might surprise you that the first reported gold in Colorado came from placer deposits southeast of the city of Denver, in the middle of the plains and far from the ore deposits in the Rocky Mountains, roughly within the red oval that I've drawn here. Many of the streams with gold aren't directly eroding the mountain ore deposit, so that's odd. Before I go any further, I'm showing a geologic map that I pulled from the USGS online map viewer. It allows you to browse a variety of geologic maps in the general area. The URL is shown here. I've drawn a purple fan-shaped blob. This is where the Castle Rock conglomerate is outcropping in the present day. The code TCR is used by geologists on their maps to represent Castle Rock conglomerate. The T stands for Tertiary, which is a geologic epoch when the rocks were deposited, specifically in the Eocene period, about 35 million years ago. By far the best map of the Castle Rock conglomerate were made by John Thorson, a consulting geologist who did the work for the Colorado Geologic Survey. At this point, I need to give a pitch for Kevin Singel's book, which is the Bible of Colorado gold prospecting. Kevin gives a great geologic summary of how the Castle Rock conglomerate puts placer gold in very non-intuitive places in southeast Denver streams for amateurs like me to find. It's available on Amazon and definitely worth the money. Kevin also operates an excellent website called Finding Gold in Colorado, where he gives a great description of how the Castle Rock conglomerate brings gold to Denver streams. The purple blob looks an awful lot like an alluvial fan, like I show in the cartoon here, with sediments coming out of a narrow mountain canyon and widening into a braided stream system. But where is the narrow mountain canyon? As it turns out, the narrow mountain canyon is Coal Creek Canyon, created by Ralston Creek just north of the city of Golden, Colorado. If you have any knowledge of current day topography, this seems kind of strange, since the head of Ralston Creek is currently below the deposits of Castle Rock conglomerate further to the south, so streams don't usually flow uphill. So therefore, we can conclude that the Palmer Divide area, where much of the Castle Rock conglomerate outcrops occur, has been uplifted relative to the rest of the Denver Basin in the 35 million years since the conglomerate was deposited. There's a good paper which I show here that describes how the Castle Rock conglomerate was deposited. Specifically, geochemists have been able to match microscopic zircon crystals in the Castle Rock conglomerate to the same family of zircons found in Precambrian quartzite outcropping in Coal Creek Canyon, many miles away. For gold prospectors, the quartzite is probably the ore rock containing the original gold deposits, which have been reworked into placer deposits. But as it turns out, the Castle Rock conglomerate isn't so simple, as Kevin mentions in his book. The sediments from Coal Creek Canyon are actually interbedded with eroded Pikes Peak granite, which washed into the basin much closer to the west and which doesn't contain gold. Geologists were able to differentiate between sediments coming from Coal Creek Canyon and sediments coming from the west by the presence or absence of the Coal Creek quartzite, which I will remind you contains the gold. The further south you go, the less the Coal Creek quartzite is present. The further north you go, the more quartzite and hence more gold is present. Here are a few images from the paper. The top two show that the conglomerate is a motley mix of rocks, and both of these samples contain Coal Creek quartzite. The bottom image shows an outcropping of the Castle Rock conglomerate fairly far to the southern edge of its provenance. It's about 100 feet thick. In these places, we have sediments coming from the north, which contain the gold-bearing quartzite interbedded with the non-gold-bearing sediments coming from the west. Here I've drawn the major stream systems which erode Castle Rock conglomerate and hence gold into the streams of southeast Denver. There are other gold-bearing streams further east, but I haven't drawn them. Cherry Creek is by far the largest of the three stream systems, and it's had gold mining activity along its length since the 1850s. Little Dry Creek and Big Dry Creek are much smaller, but do erode the far northern edge of the Castle Rock conglomerate outcrops. Gold was and is being found in these two stream systems. Here are a couple microscopic photos of gold that I pulled out of the Little Dry Creek system in Centennial, Colorado. The gold is beautiful and looks huge, but consider that the largest piece is only about 130 microns in diameter, or 0.13 millimeters. I dumped all this gold on my scale, and it doesn't even register as 0.01 grams. So with that, I'll wrap up the video. I hope you find it a useful supplement to Kevin's books, and helps you understand why we find gold where we do. Leave your questions in the comments.